This video is going to be on simplifying complex fractions. Now, I actually already made a video on this, and I talked about method 1. I called it method 1 because there are two different ways to deal with simplifying complex fractions. So for this video, we're actually going to be looking specifically at method 2. Now, just to refresh our memory, what is a complex fraction? Well, a complex fraction is a fraction that, well, contains fractions. So, for example, it makes more sense when you see it. 1/2 plus 2/3 over 3/4 plus 5/6. This is a fraction, one big fraction. You see, here's my fraction bar. But in the numerator of my fraction, I have two fractions. And then in the denominator, I also have a sum of fractions. So my fraction contains fractions. That's what makes it complex. So in method 1, we talked about how you can treat the numerator and denominator separately and think about fractions as being division problems. For this method, we're going to change it up a little bit. And instead, we're going to ask ourselves, between all of my little denominators, so the 2, the 3, the 4, and the 6, what is my LCD of all four denominators? And if you watch the first video, you'll notice this is the same exact problem, and that's because I just want you to, I don't know, believe me when I say that both methods work. So what is the LCD, or the LCM, of 2, 3, 4, and 6? Well, that's going to be 12. But since these are fractions, we typically like to multiply fractions by fractions, so let's think about this as 12 over 1. Okay. Well, now what I'm going to do is I'm going to multiply all four of my little fractions by 12. Or, since they're fractions, I'm going to use the 12 over 1 version of 12. So multiply by 12 over 1, multiply by 12 over 1, multiply by 12 over 1, and multiply by 12 over 1. Now the next step is to simplify cross-cancel, cancel everything that can cancel. So over here I see that 2 goes into 12 6 times, 3 goes into 12 4 times, 4 goes into 12 3 times, and 6 goes into 12 twice. Now let's actually write down what this simplifies to. Well, this is 6 times 1 over 1, which is 6. 2 times 4, which is 8, over 1, which is 8. 3 times 3, which is 9, over 1, which is 9. And 5 times 2, which is 10, over 1, which is 10. So after I did all of this work, it turns out I no longer have a complex fraction. That's what makes this method so cool, is there's no dealing with, changing it into a division problem, because now it's an easier problem. My complex fraction is cleared out. So now it's just a normal fraction problem. So 6 plus 8 is 14. 10 plus 9 is 19. And I'm done. This can't be reduced. 19 is prime, so I'm done. Let's try the other problem that I did in the other video. This one will be a little bit different. 3 plus 5/6 over 1 plus 5/3. Now again, I ask myself, what is the LCD of all of the denominators in my problem? Well, 3 and 1 are not fractions. They're whole numbers, so they don't have denominators. So I don't even have to think about them. I just have to think about the 6 and the 3. So what's the LCD of 6 and 3? Well, that's simply 6. So now I will multiply everything in my fraction by 6. Well, sometimes I might actually use 6 over 1 because that's also 6, and we like to multiply fractions by fractions. Well, with the 3, it's a whole number, so why use 6 over 1 when I can just use 6? For this one, I'll use 6 over 1. For the 1, I'll use 6. And for the 5/3, I'll use 6 over 1. So I have multiplied all 4 of the terms in my complex fraction by 6. Let's simplify. 6 goes into 6 evenly one time. 3 goes into 6 twice. And what am I left over with? Well, 3 times 6 is 18, plus 5 times 1 is 5 over, well, 1 is 5. And 6 times 1 is 6. 5 times 2 is 10 over 1 is 10. So that leaves me with 23 over 16. And I'm done. 23 is prime, so I know it can't be simplified. So if you've watched method 1, you'll see that method 2 actually is a lot less steps. It's my preferred way. I think it's a lot faster. You just have to remember the biggest thing is find the LCD of everything and then multiply all 4 terms by that LCD. It has to be all of them. Otherwise, it doesn't work. Think about it as whatever you do to one term, you have to do to all. So since I multiply one term by 12 over 1, all of them must be multiplied by 12 over 1. The other thing to keep in mind is that after you've multiplied everything by the LCD and you cancel, if you're still left over with fractions, then you made a mistake. And precisely your mistake was that you either canceled wrong or that your LCD is wrong. So, for example, if I chose that the LCD was 6 instead of 12, I would have ended up still with a fraction somewhere in here, and that would have been a key that I chose the wrong LCD. So keep those things in mind, and this method is actually really easy and really fast, and it's not very intimidating. Okay, that is method 2 of simplifying complex fractions.